So welcome everybody to the next event in the Data Science Academy seminar series. So today we're delighted to have Lewis Wilkins from BJSS. So BJSS is a technology and engineering consultancy company with head offices in Leeds, but they're based many offices all over the UK. And Lewis is based in London. So BJSS have worked with many organisations, including the NHS and a number of charities. And Lewis is a data scientist, and he's going to talk to us today about the use of data science inside BJSS, and more specifically about MLOps. So without further ado, I'll hand over to you now, Lewis.
Thank you. Cheers, Harry. So yeah, hi. Yeah, I'm Lewis. Actually a data engineer. I'm not a scientist. So, but yeah, I like to, there's a distinction somewhere, which I might come on to. But yeah, thanks. Yeah, thanks guys for having me. I'm going to try and now share my screen without showing my whole laptop off. How's this going to work? Share content. There we go. Sorry, I'm again not used to Teams desktop. Right. Let me now try and.
Yes, we can see it.
Can you still see it?
Yes.
Yep.
Perfect. Okay. Yeah. So yeah, my talk today is going to be on MLOps in production. Kind of a what. It's supposed to be what, why, and how. Got a typo in the first one. Yeah. So to start with, yeah, I'm Lewis. I'm a data engineer based with BJSS. I've been with the company for about 10 months now. In a previous life, I was a physicist, and I've moved over into industry, working to help, companies build out their sort of data platforms. So a bit about BJSS, a bit more anyway. Yeah, we're a leading technology and engineering consultancy, started back in 1993, based out of Leeds. I've really now expanded across the country to, I think it's 13 or so offices, from all the way down from Scotland, Cardiff as well, and London, Birmingham, and everywhere in between. Expanded out into the US actually as well. We've got it's in Houston and New York. This coming, well, in the lockdown actually, we started one in Melbourne and Lisbon. So really expanding not only in the country but across the world now. Started originally doing software for trading platforms as far as I know, but really expanded into all sectors you could think of, from finance, healthcare, energy, government. You name it, it's probably something we've looked at. Over about 1,500 of us now working, and I think it's more like 1,700 actually. So really expanding, and the data team is a bit newer. We've probably started about 5 years ago with the data science capability, and that's slowly grown to about 2 years ago. We got a data engineering capability, and that's really blown up in the last year to there's about 70 of us now, probably half data engineering and then half across data science, MLOps, data analysis, data architects, that sort of thing. So really sort of a wide breadth of skills that we get into. So this talk's going to sort of, like I said, outline a bit about MLOps, so the what, why, and how. And then I'm actually going to dive into one of our engagements we work with a Cardiff-based company of Confused.com. We worked with them for about 6 months, and I'm going to talk a bit about what we did there, the implementation of how we did it, and what we sort of learned from it, what was good, what was bad, and then finally sort of a few of my musings on the field. The things that I think are important, sort of, I guess maybe from that transition from academic to industry, and then what to look out for, I guess. So MLOps, or MLOps as this looks like, what is it? So this is what you call machine learning operations, and for me, it's this sort of intersection actually of data science, data engineering, and DevOps. For those of you who don't know DevOps, if you're coming from more of a data science background, DevOps is a common paradigm in software engineering, where you have this kind of this blue and yellow infinity sign here as you go through your development life cycle. So you will you write some code, you build it, then you continuously test with things like continuous integration and continuous deployment systems. You then release it, deploy it, operate it, monitor on it, and then maybe you come back, plan, add a new piece of feature. That's a new bit of code, then you rebuild it, and you have this continuous cycle that we call DevOps. When you add in machine learning, you're adding on a kind of an extra element here. You're adding this stochastic element, this model that you're building that's based upon real data that changes, which means that has its own cycle in itself, where you have to, define a problem, gather the data, explore how it works, build a model, evaluate it, but then the data changes, so you need to redefine it, regather, and so on. And that becomes a cycle that you need to bolt onto this DevOps And for me, that's what you would sort of call MLOps. Now, the difficulty with this is really, for me, it requires both R&D and engineering to work at the same time. Now this is like, if you imagine you've got to build a bridge, you're an engineer, but as you're still building it, you're still deciding on like the materials you're going to make. You're actually developing the concrete or you're developing the steel to build it at the same time as you're actually constructing it. And that makes it very difficult because normally you would build pre-built components that work. So like in software engineering, you tend to use a ready-built library that you know about. For instance, in data science, you've got pandas. You wouldn't go and try and reinvent that and develop that in real time as you're working. And I think this is an issue that comes across in MLOps, is it becomes quite difficult not to do that because of the nature of machine learning models being almost like a living thing. They're not a solid piece of code. And again, for me, I would say it's not yet a solved problem in the way DevOps is. I think in software engineering especially, we've got to the point where DevOps is pretty well set. We know what goes in a continuous integration pipeline. We know what goes in your build pipeline, your deployment pipelines. We know about where to do tests. We've got good tools for it. They're all sort of already there. MLOps, I think, is a very emerging field. It's really come about in the last 5 years. So yeah, that's kind of what MLOps is for me anyway. So what makes it up? I think this is a really good paper if anyone's really interested in machine learning systems from Google. It's called Hidden Technical Debt in Machine Learning Systems, and that's a link here. There's a few links in the back of this as well. So this kind of gives you an overview of what is involved in deploying a machine learning model. So in the middle, you've got your ML code. This could be your scikit-learn, your TensorFlow model, your PyTorch model, whatever it is. That's a really, really small part when you're deploying this at scale. You've got so many things around, data collection, data verification, your feature engineering, automating all of this, any sort of logging and monitoring, keeping story of your metadata, infrastructure that you're building this on is in the cloud. There's so much around this that goes towards it, but it's not just, when you're building, you're doing a sort of a data science project, you just think about, you've got to build this bit of code and maybe in a notebook, you've got a nice model, you fit to your data, you test it on some new data, it shows up some good results, brilliant. But how do you get that going in a business setting where it needs to be reliable, it needs to be robust, and it needs to have good uptime? It's very different than just having a script on a Jupyter notebook, for instance. So why do we need MLOps? And I kind of probably touched on this a little bit here. So in the middle, I've got this diagram again I nicked from another paper. I can't remember which, it might actually be the same paper, which shows kind of the difference between a traditional software system and how you would test and monitor it versus an ML-based system. So here you have kind of talked about in your DevOps, you have your code, you write some unit tests, integration tests, there's some monitoring, and there's a running system that you deploy it into. That's pretty well known about, but if you get into machine learning, you've got all sorts. Really what the main thing you've got is your data coming in, which is this ever-changing element that is stochastic, which is something that is much more difficult to keep on top of. So you've got to test your data, you've got to do SKU tests, data monitoring, model testing. How's the model behaving? Is there any model drift? Is the infrastructure still working? And monitoring in general the system, are we still getting the same results that we expect? Has it got right uptime? Has one of the VM's gone down? All these sorts of things need to be kept look at. So it's a much more complicated system. So this here is production ML is hard. There's also the classic, I'm sure you've all heard it before, that essentially 90% of data projects never make it into production. This is why we need MLOps, is in order to help with this ability to fail fast. This is something I think is very important, and I think businesses can sometimes not see this when they have a new data science team, is understanding that it is science, and you will fail most of the time, and that is just the nature of science and experimentation. But with a good, robust MLOps system, it means you can fail fast, and when the ones do work, it's very quick to put it into production and make sure that it then brings back its value in the real world. So on that, I guess, again, is that there are a large number of businesses that now want to leverage ML. It's often called, we're in the data age now, where companies have realized that there's a lot of money to be made, extra insights they can get out of their data, customer behavior, how we can come on to now about how we can, encourage customers to buy more often or buy other products. And so companies really want to leverage this and get the value that they can out of it. They've seen the big tech companies do well out of it. You hear all these crazy stories about what AI and ML can do, and they want a slice of it. So MLOps is really needed to help bring this into the business world. And I think this goes on to the final point, which is machine learning is now moving from being a research topic into application. Like a few years back, the majority of roles you'd see to do with machine learning were machine learning researchers who are really looking into developing state-of-the-art algorithms. These would be places, like Google's, your DeepMinds, your Facebooks, who are, really trying to push the cutting edge of crazy deep neural networks, or like recurrent neural networks, or you've got things like reinforcement learning doing at DeepMind, all this really cutting edge stuff. Whereas now it's sort of filtered down that we've realized for a lot of problems we can use kind of the really steady, well-known machine learning algorithms that work pretty well. And that means that we now need to start applying it to things rather than just a pure research topic. So I think this in combination is kind of why we need this MLOps and why it is useful for businesses. So how do we do MLOps? What tools are there is what essentially what I'm getting to here. And this is another one of these famous diagrams with all the data landscape in it. There's loads of stuff. So when I said that this isn't a solved problem, I didn't mean there aren't any tools. I just meant that, good tools are probably not all ready yet. And a lot of this is very new tech. A lot of this hasn't been around for very long. So you have all sorts for, your machine learning libraries that I'm sure many of you are aware of, things like scikit-learn, TensorFlow, PyTorch, things like that. Similarly for deep learning, reinforcement learning, and common languages that you're using are sort of, Python generally, sometimes a bit more, or sometimes Scala for a lot of the data processing stuff. Then you have ways of using notebook environments, which are very popular in data science for doing your EDA and your model development sort of things. So things like Jupyter, Databricks notebooks have come along recently, which we'll come on to actually. And in the data sort of area, you've got everything from versioning. So data versioning is becoming a really big thing, which again, I'll come on to. I think is very important in this sort of thing is bringing in some of the good practices of software engineering versioning to data and to your models. There's cool stuff now around sort of explainability in your models. So very important when you're speaking to some business stakeholders that, you can tell them all about this fancy deep neural network you've done, but they want to know why is this thing making this decision, and giving some explainability to it is really important, I think. And so there's a lot of tools out there now that try to help bring a bit more sort of, explainability out of these more complicated models that are quite abstract to explain. So like I said, the landscape's huge. There's a lot of stuff involved. And I'm going to sort of show a bit about what we did and how we organized things with this handy diagram. So I found this template, which is really nice, and it kind of breaks down the main key areas that you need in an MLOps stack. So it starts with your data analysis, like I talked about, which is probably often done in Jupyter notebooks or something like that. And same for experimentation. Something for your code repositories. This is like your GitHubs, GitLabs, Azure DevOps, things like this. Feature store is something I'm going to talk about. It's something I really enjoy. I think a fascinating development in the last few years. So this is where you store all your features, essentially. Something to run your ML pipelines, so orchestrating, making sure the ML training and serving is done automatically. Model registry, again, is like your code repository, but for models, is probably in the name. Again, something that I think is often overlooked and is really important to have. And then you have model serving and monitoring, so getting that out to whatever application you're using for. Is it a web hook where people want to, on a website where you're clicking and you need some response quickly? And there's things like metadata stores, which are very important again for keeping track of your things like your features, your models, and so on. So that's a brief whirlwind through the kind of the landscape of MLOps now. So to a specific use case, so we worked with Confused.com. I'm sure you've seen their adverts. They've been around for years, and it's this insurance comparison website. There's not much more to it than that, really, but they probably had quite a small data science capability and really wanted to mature that and bring it to production level. So we worked with them to redevelop an existing machine learning model with some features that they had, and then productionize the redeveloped model using the best practices that we consider in the industry at the moment. So the model itself, the idea was basically to predict if a customer was going to buy a product in the following month. It's a pretty straightforward problem there. The features can include things like the expected number of months to renewal, number of quotes in the past year, things like that you would expect were going to this sort of model. And so what we used was a boosted decision tree, which is implemented in scikit-learn to do this. And so pretty much out of the box, trained on a given month set of features and used to predict the future months. So for example, we would have February, and we would use features that were from February backwards to try and predict whether they'd buy in March. This was, like I said, pretty out of the box BDT implementation. There was a small bit of hyperparameter tuning, but nothing too extreme. yeah, so that was kind of the model, which was probably for me not the most interesting bit. Here's kind of an overview of the original implementation. So there was a Azure SQL data warehouse with some stored procedures, which produces the features and the labels, and then some model training and serving done out of a Jupyter Notebook, which produces an audience, which then allows them to send off emails using Adobe Campaign, which would set up a marketing a marketing email campaign, that's the word, based upon the audience that was produced from the model. So what we wanted to do is bring this into a more robust and productionized system. So what we did, again, to use this nice diagram of the stack, for our data analysis, well, driving a lot of this was Databricks. So if you don't know, Databricks is basically a managed Spark instance service that's available on Azure and now AWS. Actually, it's made by the people that wrote Spark originally, which is a big data processing tool for parallel processing large data sets, and they built this really nice managed service on top of it, which allows you to have notebooks like Jupyter Notebooks that interact, but they allow you to use Spark within them. So it's much easier than setting up your own Spark instance and having to worry about provisioning a load of a cluster for yourself. It does it all for you, which allows really good interface for doing exploratory data analysis with large data sets, which is perfect for this. So both the experimentation and data analysis was done with Databricks. The feature engineering was out of scope for this project, but we basically had some SQL stored procs that pulled them from data warehouse. So they had the raw data in there and then pulled them into some set of features that were decided on before. So then for our feature store, we built a custom kind of one based upon Delta Lake, which I'll come on to slightly in a minute. A code repository stored in Azure DevOps. The ML pipeline was orchestrated with something in Azure called Azure Data Factory, which is just essentially an orchestrator. Tells it when to run things and in what order. The model registry is a really cool tool called MLflow, which you can think of as essentially a registry with the list of all your experiments you'd run, each of the models, which hyperparameters were used, what features were used, and what the final accuracy and your metrics are based upon that, and you can basically rank it, work out which hyperparameters were best, pick the correct model, and so on. All that sort of stuff is also the metadata store is also combined with the model registry in this instance. And then the model serving, it was actually just served out of Azure Databricks because we didn't need anything like online online serving yet. It was still done by batch. And the model monitoring was done sort of a custom sort of setup using Azure Log Analytics. So it was an Azure heavy, well, it's basically a pure Azure tech stack. So one thing I really want to talk about, which I kind of briefly touched on, was feature stores. I think these are cool and is something that are interesting and becoming more and more widespread in MLOps. So to roll back a little bit, in case anyone isn't aware what a feature is. So a feature is normally just a derived piece of raw data that is something that you can use as an input to a model. So in the case of this example here, the feature here, we've got one called in foreign country, true or false, or size compared to average transaction. And then you've got these two features here, which are trying to predict a label called fraud here. So presumably in this model, they'll use some combination of this. So yeah, you can just think of features as derived raw pieces of data that are used as an input to a model. And now I've used a lot of diagrams from this Tecton blog, which is really cool on what's a feature store, and I recommend looking at that for a bit more in depth. So feature stores, why bother? So they really act as a one-stop shop for your EDA. It contains all the features that you might want to use. I mean, you can do them in different ways, but the idea is that you have any feature that's possibly be used for any sort of models in one place, which means you've got a single point for both pulling your training data and your serving data from. They both go through the same pipelines to derive them. They both have the same to make scaling or imputing applied to them. It also means you've got very good data lineage. You know exactly where the data came from, how it came to be about, and what the process was that led to it, which is becoming really important generally in data engineering. Is a big problem with data lineage and trying to map out, how a piece of data has arrived at where it is and what it's gone through to get there. It's very much an unsolved problem and something that a lot of money and time has gone into. It's consistency, like I said, and it's also simple just to add new features. It's a case of just adding on an additional piece of logic that will produce produce your feature. So generally you might have two different sources, like a batch source and a stream source. So batch might be you get monthly reports from someone that's batched in and that derives some data from it. A stream source could be, you know, click streams from the internet, you know, an Internet of Things device. You know, there's various different ways of doing it. But within the feature store itself, you have a mainly sort of 5-6 components. So you have your transforming component, which is what builds them. So this is what is turning your raw data into your features. Some sort of storage layer, where are you storing it? Often data lakes nowadays, things like S3 or as your data lake or blob storage. You have some way of serving it. So this is how you're getting it back out. Always important in any software engineering production software engineering project is monitoring, so operational monitoring to check that, you know, the pipelines are running correctly. This could also include things like data drift. Has the data changed over time? Are the training and serving sets still sort of staying in line? A registry, which is where you kind of, we called it a feature catalog, or it's often called a meta store, to basically store what are the features you've got in here and any metadata on them, perhaps. You know, are they string type? Are they integer type? What's sort of the expected range of them? What are they sort of called? Another bit is on-demand transformation, which kind of comes from the stream source. If you've got a stream coming out of it, you need something that does on-demand transformations very quickly. I won't talk about that because we didn't have that. And then that you funnel it, this all goes out to your model serving or your model training. So in terms of confused.com, the feature stores, and I say stores because we use two, which I'll explain. I've again augmented this nice diagram for us to show what we used. So the batch source was the data warehouse. We said it would land in a CSV or Parquet file, which we would load into the feature store. Databricks transformations, so Spark transformations to build any scaling or imputing, things like that were done in that, or some slight combinations of them we used. Our registry was just a simple JSON file actually that we kept. It would have been good to expand on that, but not really any chance. The storage is stored in Delta Lake, which is Delta is basically built on top of Parquet, which is a columnar storage format. But what Delta adds is ACID transactions to your Parquet files, which means that you can almost have a data warehouse-esque level of like schemaing and making sure that you know what transactions have happened when, but also have the cheap storage of blob storage in things like Azure Data Lake. And then operational monitoring, we stored all the data, aggregated data, or the information about the data drift in additional Delta tables that could be then turned into dashboards later. And then it was, like we said before, it was served from Databricks, and we had no on-demand transformation. So we built a custom API for accessing this feature store, which allowed a single point of entry and exit from it. So you read from it with, you know, featurestore.read, and you load into it with featurestore.load, and that was it. We had it meant that throughout the code base, you only had one way to interact with it, and it made it very easy to use it in different places, and also made it very testable, which I think, again, is something that's very important in software engineering. So the feature stores, why I said S as in multiple, we had a generic feature store which holds just all the untransformed features, we called it, so no scaling, encoding, or imputing, so they could be used across many different models. But then there was also a model-specific feature store, which would be specific to any individual model, where specific transformation parameters have been applied. So this may mean you did standard scaling on one, min-max scaling on another, impute in a certain way. And that would mean that then in that specific feature store, they were used for, you know, model A here, model B here, but they all pulled from this generic feature store, where you could also pull to do your exploratory data analysis or something like that. So the key here is that there was reproducibility was possible. You know, if we got down into the future and the model started behaving badly and we wanted to go back in time and work out what happened where, we could reproduce exactly the situation that we had, you know, X months ago by having this. These feature stores, I should probably have mentioned, are also versioned per batch. So each batch comes in, you get almost a new feature store or a new kind of partition to it. So you can definitely reproduce something moving forward into the future. So I think feature stores are really powerful. I think it was Uber and Netflix maybe who really pushed them. Uber's got a really cool data platform, which I've linked to in the backup slides, where they talk about their whole ML platform, and they really emphasize the need for feature stores. So the lessons kind of learned in this, and this is kind of more partly my musings as well, but it's really important that in any of these data teams, moving forward that siloed working doesn't really work effectively. You can't have a data science team, a data engineering team, an automation team, a testing team individual. You need them all to work together, and everyone needs to kind of know what everyone else is doing. You need a top-down view from somewhere, because unfortunately, it's not like software engineering projects where everyone can do everything, because software engineers are generally, they're all pretty sort of skilled in doing any part of a project. Because data is treated like a software engineering project, but it's not, because people, a data scientist still needs to be an expert in statistical methods and machine learning models, things like this. An engineer still needs to be an expert in building robust, scalable, efficient code. But they still want to know how each other works in a kind of symbiotic way. Otherwise, it doesn't really work for me. This is say get end to end as soon as possible, building out your pipeline from end to end, whether or not it's basic as much. But if it's really basic, that doesn't matter. Just getting it end to end and then build the complexity on top of it. And that kind of lives with the keep it simple, stupid mantra as well. And having a strong design up front, although often these projects are agile, it's really important to actually have a strong design architecturally of what you're gonna aim for, and then sort of iterate on that only a little bit. And the other thing is testing is really important. As data scientists, often we don't think to do this because it's not really part of our remit, we think. But this kind of goes back to what I'm saying, is that you do need to know about what the other side of the table are doing. So engineers are doing, they will concentrate on building that testable, reproducible code. It's something that data scientists and ML scientists also have to think about in when you're building these production systems. And it will save you, and it saved us a lot of time when a unit test thrown up, that something isn't actually doing what we think it is. Saves you a lot of time down the line, building that in and not realizing until you've shipped the product, sort of thing. So my final musings on it. I think the key one I want to take away, sort of people to go away with, is that is the idea of this not having siloed working. Machine learning projects or data science projects in general are complicated, and there's a lot of different sides to it, but you need all these different expertise coming together into one. You all need to know from a high level what's going on and why decisions are being made, because if you don't, decisions can be made in a corner that affect another corner, but they don't know about it, and it's not until too late that you realize the design decision is sort of almost ruined. Not ruined, but caused some major issues. And the other thing is to sort of remember this kind of the software engineering side of things when doing data science, because it's becoming ever more important as we move from like I said, a research thing into more of a production application world, that businesses really need to really need robust systems that are going to be scalable and reliable. So that's my end of my musings. Sorry, I've gone on quite a while there. Thanks for your time, and I'm happy to take any questions anyone might have.
Okay, so thanks very much, Lewis. If anybody wants to ask a question, you can unmute yourself and ask the question, or you can simply type in the chat. So I'll start off with the first question. So you mentioned that it's important not to work in this kind of silo nature. So what kind of tools or best practices could you recommend to help organization and improve communication between large teams?
Yeah. So for me, we tend to, in BJSS especially, we work in a kind of an agile environment where you work in sprints every couple of weeks, and the whole team will be involved in things like sprint planning. That means that everyone kind of should know what's going on across the board in all the different sectors of the project. So that means that you're at least partly privy to what's going on. I think the other important thing is regular show and tells from each individual, not silo, but each individual department, to try and keep that message across about what the kind of the final goal is and how it's being built up and what the implementation looked like from different sides, and making sure that in sort of planning sessions or times when you're designing up making big architectural decisions, there's input from all of these points, so that litters down. And I think it's also about keeping everyone interested and giving people the opportunity to get involved in the different sides of things. So something at BJSS we're quite keen on is making sure that although you might be a data engineer or a data scientist, you don't just sit in that capability. You are able to pick up things and work on different projects or get experience in your own time with learnings and stuff. I think it's important that everyone tries to cross skill as much as they can in that sense.
Okay, thanks. So, so you work in a large technology consulting company. So I'm sure we have a lot of students who are considering maybe similar careers. So could you maybe describe what a day in your life looks like? Is it a lot of meeting with external clients? Do you do a lot of coding? Is it a lot of management?
Yeah,
What sort of activities do you do in an average day?
sure. Well, today's not an average day because it's been meetings all day. No, but generally, it's very varied. It is very varied, and it will depend a lot on the project. So yeah, working with Confused for me was really great. It was a lot of working with the client and spending a lot of time doing things like, well, that was quite an interesting one because it was building something from the ground up. We spent a lot of time doing the planning, architectural design decisions, but then also working with the client to help upskill them. So a lot of time doing pair programming and delivering knowledge transfer sessions. And then there's a lot of opportunity there to interact with the business stakeholders on their side to make sure they're happy with what we were doing. At the moment, a lot of my time is actually spent coding. It's on a more coding heavy project now. But then that sort of, again, is a slightly different project. So I think, especially with consultancy, it's a classic answer. It really depends on your project, but it's always going to be very varied because there's such a wide range of things you can do. And because we don't like people to sit in their sort of silo, it gives you the opportunity to move across into all different facets of it, which I think is really interesting.
Okay, thanks. Are there any other questions from the audience?
Thanks, Lewis, for giving the presentation. I was just going to ask if you could sort of give an overview of some of the terminology that you've used. So you obviously talked about software engineering and data science, which I think a lot of us will be familiar with, but then you've also talked about data engineering, and I was wondering if you could sort of expand on what the specific differences are between those and data engineering.
Yeah, sure. So yeah, for me, data science is those that are working with probably more directly with the business on what the business problem is, looking at the data that they have and how they can answer the question with the data. Data engineering is more about enabling them to do it. So it's often building the data pipelines in general. So a project I work on now, we're building a big data platform in the cloud where we ingest data from several different data sources, and we have to transform that in an appropriate way and place that into a large data lake on the cloud. How that differs from software engineering, in my opinion, nowadays, the modern data engineer, as I call it, is very much a software engineer within the realms of data. So they'll be familiar with distributed computing. They'll be familiar with probably cloud platforms. So we do a lot of Spark now for this big data processing, but still having that key kind of software engineering qualities that you'd expect. Whereas often, yeah, your data scientists they're scientists in that sense. They're doing experiments. They're doing more ad hoc kind of coding. They're still doing coding, but in a kind of normally in a less stringent way, as it were, that you'd have in data engineering. And then there's also the side of things when you're interacting more with things like database technologies. So for me, the old school, as it were, data engineer normally comes from the background where it's more of a DBA, a database administrator side of things. So working with SQL databases and how interacting with those, whereas the modern data engineer sort of brings in kind of all of these things and is building basically the pipelines and platforms that can deliver data, in the appropriate way to help out businesses.
Okay, cool. Thank you.
Yeah, so I think it mentioned on one of your slides, Lewis, that BJSS have won a number of awards. Could you tell us something about that? Some of the awards that the organisation has won.
Oh, I'll have to look at it because where's it gone? So I know we got it's the Queen's Award for what's it? Yeah, called the Queen's Award. I think that was in 2018 for this enterprise agile approach. So we basically wrote a book on agile, which is this ways of working methodology that it underpins most software delivery projects are often in agile. So this is the idea of working in sprints. You break down all of your tasks into user stories and people pick them up, and then you have certain ceremonies around this. So every couple of weeks you'll have sprint planning, you plan the sprint ahead and so on and so forth. So we won an award for that apparently. And then there's a few others here which to be honest with you I'm not 100% sure on because a lot of them were before I joined. But I hear they're good.
talk to a couple of those if you
Yeah,
want.
thank you, Kate. Thank you.
Shall I save you there? Shall I? So we won. It was the Queen's Award, I think, for innovation. We won, so that was actually quite a big deal, and very exciting. As Lewis said, we've got an agile approach that we've had for many years. We have books. I have 200 copies downstairs if anyone wants one. We've won loads of awards. So we are gold partners with both Microsoft, with AWS. We do a lot of work with them. We're also exploring Google at the moment and other technologies. So even though we are very much technology agnostic, so we will typically be led by the client, what technology they use, and occasionally they will absolutely ask us for recommendations on what we think the best product is. But we don't build products. I mean, our only commodity is people. And so, what we do is we sell very clever, talented people to work with our clients. And I think I was actually talking to Confused earlier, and we were talking about this bit of work. And it was a really, really good project. I think everyone enjoyed it. And I think one of the key outputs for them, or outcomes rather, was to kind of strengthen their in-house capability, which is broadly what we do with all of our clients. But this was a very sort of tangible outcome they were looking for. So the ability for their people then to do these kind of engagements and not need us anymore. No, it was a really, really good bit of work, and I think it was a really good sort of collaborative approach. And the entire thing was done remotely, so it sparked up last summer. So none of us have met any of us. I've never met Lewis in the flesh. So we did all of this remotely. So I think someone asked, sorry, I forget the name, around tooling. So as well as everything Lewis said, of course, we use Zoom, we use Slack, we use Teams, we use every possible collaborative tool going. And actually we have found those to be really helpful in, it's allowed us to keep going really for the last sort of year and work with lots of new clients in this kind of environment.
Yeah, so just one follow-up question. So you provide education to companies. So do you believe that you offer a different value proposition to, let's say, universities who also provide, let's say, CPD training to companies?
Oof. This feels like a trap. I don't know. I don't know what the answer is there, I guess. I mean, as I say, our commodity is people. I guess where people engage us is that we work with a lot of different clients. So we're in that position to go, actually, we're constantly looking forward, what's the next technology? What should we be investing in? Where should we be having people upskill? So, upskilling our people is a huge part of what we do, so that we are able to offer fully qualified individuals. Because we recognise, people can go to the contract market, they can go elsewhere to kind of buy the skills that we're able to provide. But I think what we pride ourselves on, I guess, is that ability to be independent. So we're not out there touting what we think clients want to hear. We will be honest, we will be direct if needs be, but ultimately we're looking to build those long-term relationships so that once a client works with us, so Confused is a good example, we're talking to them tomorrow about a new bit of work actually where we've built that trust, we've done a really good delivery together, and they trust us now. So actually they're looking to go into a different area. So we're having a conversation tomorrow that says, okay, how would we do this? What would that look like? What would the combined team look like? And also let's kind of get the risks out of the way early doors. So where might this whole thing fall over? Let's kind of get that on the table early so that we're in a position then to kind of go at this together.
Yeah, it sounds great. It sounds to me like it's more, you provide a bit more of a bespoke solution to clients than maybe a university can offer.
It could be, yeah. I mean, sometimes the client wants us to build a thing, and we'll build the thing. Yeah. Sometimes, an off-the-shelf product will do the job. Other times, it's actually going to be a heavily customized solution. I guess to Lewis's point, there is no typical day, and every client is very different. So it's working that through with them together to understand actually what's the right answer for them.
Are there any other questions from the audience?
Just going to ask, obviously, you've said that the business has expanded a hell of a lot in the last 20 odd years, and data is obviously one of the newer parts of it. Where do you see it going? What's the sort of next stage?
I don't know really. I mean, within Cardiff, the office, we kind of got things going about a year ago. Great time to kind of launch a new business. But we're now at 30. So I've hired 30 people in the last year, and I'm looking to at least double that by the end of this year, if not triple it. So as a business, we're in a very nice position where we have more work than people to do it. So some of the newer offices are taking advantage of that because, again, everything is still remote pretty much. And so where we conduct the work is here nor there to most of our clients. So that allows us to kind of create teams that can be based all over the shop. So I think we're certainly expanding. I think we are looking at new geographies. As Lewis said, we've opened 2 new offices in the last 6 months or so. There are other countries being looked at the moment, but I guess we'll just keep listening to our clients. You know, if they ask us to kind of move into a new area and we think it's got legs, we'll to a degree be led by them. You know, so we're constantly kind of looking forward and saying, where should we go?
And have you got openings for students, you know, who are looking to go on to this as first career? Have you got, you know, like graduate opportunities and things like that?
We do, and we are hiring big time. So if anyone wants a job,
there you go, students. Listen to that.
Yeah, we have. We've got a graduate academy which has 2 intakes a year, so March and September, and we also have a data academy. Which is for those who want to specialise in data. So actually, I've got one of my graduates who joined the business in March, loved the data element of the academy, and has gone straight into the data academy. So she's on that at the moment for, I think that one's, is that 5 weeks, Lewis? It's slightly longer, I think, isn't it? The data.
We finished it this week, so yeah, it would have been 5 weeks. So this is something I've been heading up actually, which is I think is a really cool thing that we're doing. So yeah, there's 2 intakes of that a year. If you want to look it up, it's called the BJSS Academy.
Yeah.
There's openings at the moment for the June one as well, and then I think they run, is it September and March for the graduate one?
I think so. I mean, we've turned that kind of inward as well, because a lot of our people, some of whom are on this call, are interested in data, so they can go onto it as well, because it's a really good kind of crash course in how to do all of that very clever stuff that Lewis talked about.
Okay, sounds good.
So you have an office in Cardiff, is that correct?
We do.
Okay.
And we are hiring, just say that again.
Okay.
Anyone looking for a job? You see me. So yes, we are. And as I say, we've got local clients. We've got clients in Swansea and Cardiff, a couple in Newport. But actually, because of the way we're working at the moment, we've got people who are joining us and working. So one of the guys worked on a project, I think it was Goldman Sachs in New York, was his first project. We've got other people working on various stock exchange programs. We work across all sectors, really. So the good thing at the moment is, if the perfect person happens to be in New York and they can handle the time difference, which we are working like that at the moment. So I've got 3 guys from the New York office on a large Welsh building society project that we are running, and they have to suck up the time difference, unfortunately, for them. But it's a really good project, and actually they were the right skills we needed for that particular engagement. So away we go, you know.
Brilliant. Okay.
Any final questions?
Hi guys, I have a quick question.
Sure.
Far away.
Lewis, I definitely agree with your point about like silos and things like that in working. I know that I've been before my final year at uni, I've been on placement for a year and then part-time for a little while at quite a large organisation. And if anyone would ask me what's the biggest kind of challenge I had during placement, it was definitely like kind of siloed nature of work. And not even kind of, you know, 1 or 2 silos, but, you know, there's kind of 6, 7, 8 teams maybe that I may have come across during my time there. I also, during my placement, my team kind of spawned into a data team, kind of like what you said your team has over the last kind of few months or so. Do you have any advice for people like ourselves, graduates who will maybe join or be part of a new data team in a kind of almost legacy or kind of large scale organization, and kind of breaking down the challenges that are associated with that?
Yeah, that's a really, really good question. And it's you know, when you are dealing with kind of the older, more legacy oriented companies, it is kind of sometimes difficult to get across this message. But I think my advice would be is to throw yourself into all the different areas yourself. And there's no better than yourself to kind of lead the charge in terms of making sure you are aware of all the different silos and try and get yourself into them and try and understand, you know, you're hired as a data scientist, try and understand how the platform engineers work, try and understand how the automation guys do things, you know, and the data engineers or so on, and try and just get yourself in and amongst it. And I think then that helps people see, you know, that it is a good thing when you've got people that are able to do, you know, multiple things and have that top-down view. I think it makes you more useful and better at problem solving when you have a fuller picture of what's going on. So I think it's difficult, especially if it's you only yourself leading the charge. But I think my advice would be to sort of make sure you can throw yourself into all facets and learn, about not just your speciality. Become, I think we like to call our consultants T-shaped, so like quite a wide breadth, but you've got a T that comes down and you go deep into certain aspects. I think that's a really good mantra to have in general, and I think that's what helps with this kind of removing silos in data teams especially.
Cool. Thank you very much, guys.
No worries.
Any other questions? Okay. If not, we'll bring the session to a close. So I'd just like to thank Kate and Lewis again for giving a presentation, a great presentation, and leading a very interesting discussion and an engaging discussion.